In our last video, we very slowly worked through the formal definition of a convergent sequence. And that is a big, bad, scary definition. What I'd like to do here is just give an example of how we will be interacting with that definition in our class, which is at a lesser degree that you might encounter in other places. So what I want us to do is work with very concrete examples of sequences that have a very specific limit, and then with a very specific epsilon, given epsilon, I'd like us to find the n, the index that corresponds with that epsilon. So I wanted to give an example of the type of problem that we will be working involving that definition and show you how to do that in Mathematica specifically. So let's take as an example one of the sequences we've been dealing with in these videos, the sequence of 1 over n factorial sequence, 1, 1/2, 1/6, 1/24. The next one would be 1 over 120. First of all, what is the limit of that sequence? We've said it out loud before, but we'll go over a little bit of why. And then the second part of a question I would ask with this particular sequence is, if I give you a very specific epsilon, in this case, let's say that epsilon is 1 over 1,000, then can you find the big N for me? Can you tell me how many terms of the sequence I need to let go past so that once I hit that capital N, every term in the sequence past there, the difference between that term and the limit is less than this epsilon, which is 1 over 1,000. So that's the type of question we're going to ask. Let's pop on over into Mathematica to get started on how we would handle this type of question. So the first thing I'm going to do is start up Mathematica. I have mine right here. It pops up from my start menu. So I click on Wolfram Mathematica 12. It takes a moment to boot up. And it'll bring me to this screen. And what I want to do is create a new Mathematica document. And here it is right here. On mine, I'm going to zoom in so that you can see everything I'm typing a little bit larger. The very first thing you do every time you open up Mathematica is you ask it to do a very basic calculation. So I typed in 1 plus 1, and I want Mathematica to do this first. This is because on its first calculation, Mathematica loads in a bunch of libraries and commands. And so we want it to do a very simple computational task so that it can focus all its attention on loading in those libraries. You'll also notice that if you're working on a laptop and you hit enter, Mathematica won't do anything. That's because Mathematica is giving you the ability to space things. If you want Mathematica to actually compute, you need to hit shift while you hit enter, or if you're working on a computer that has a number pad, the enter button over by the number pad should also do this for you. If you only have one enter, like I do on my laptop, you have to hit shift while you hit enter, and then it will give us that outputted answer. So that's the first thing that you do in Mathematica. The next thing I'm going to do in Mathematica is teach it my own command. I want to teach it the sequence A of n. We need to understand a little bit about how Mathematica works as a programming language. So any programming language has what's known as syntax, which are rules of the language, kind of like grammar. So rules like we always begin a sentence with a capital letter is a syntax rule of the English language. Mathematica follows that same rule. All words in the Mathematica programming language start with a capital letter. So for example, Mathematica has a function called factorial. Look that Mathematica tries to help you. When you start typing in, these are all words that Mathematica knows in its programming language, and I start typing things in and it pops up the words that I might be interested in. I'm interested in factorial, so I could either complete typing that or I could select it from the list. Another thing Mathematica does is color code to try to help you. If you're typing in a word that Mathematica knows, it's in its language, that will be a black word. If it doesn't know the word, like factoria, which is not a mathematical command, that word is written in blue. So you can use the color to understand that Mathematica knows the command you're trying to show it. The next thing we need to do is say, well, factorial of what? 3 factorial, 4 factorial, 5 factorial. This function, the factorial function, needs an argument passed to it. So if we type in, let's say we want to look at 5 factorial, what we need to do is pass the number that we want to give to the factorial function. We need to pass it that number. We want to hand it 5. In mathematical writing in a textbook, you would use parentheses for that. Take the factorial of 5. However, Mathematica as a programming language is very, very precise. And Mathematica leaves parentheses to you for order of operations. We use parentheses in handwriting for lots of different contexts, and the computer cannot handle that. So Mathematica is going to take parentheses, and it's going to use those for order of operations only. Where we would, in writing, pass an argument to a function like f of 5 with those parentheses, Mathematica is going to use square brackets. So if we want to pass 5 to the factorial command, we need to do it that way. And again, note how Mathematica is using color to try to help you. If I put square brackets around the 5, everything is black. Black is Mathematica's way of saying everything's good. If I had used the parentheses like before, the parentheses were red. Mathematica was trying to indicate that something was bad about what I was doing, and it was using the color red to indicate that. So when I go ahead and I use the square brackets, which I will use for every single function call in Mathematica, I go ahead and I put that 5 in there, I hit Shift to hit Enter, and Mathematica will compute 120 for me. I'm going to pause right here and end this video because it's getting a little bit long, and in the next video we'll continue working in Mathematica to create that sequence that involved factorials, and we'll get back to that problem of finding the big N value for our epsilon of 1 over 1,000.